Okay, looks like we're getting started. Hi, everybody. Thanks so much for joining me here today. I'm Harsha Nori. I'm a Director of Engineering for Ether. It stands for AI Ethics and Effects in Engineering and Research. It's basically a responsible AI team here at Microsoft. And we sit under Microsoft's Chief Scientific Officer, Eric Horvitz. So today I'm really excited to introduce you to Guidance, a programming paradigm for steering large language models. I wanted to start with kind of a funny exchange I saw on Twitter recently. Starts off with a pretty innocent question. Someone asks one of these large language models to give them an example of a dictionary, a JSON dictionary, and crucially they ask, don't include any text before or after the JSON. And of course, the model doesn't quite follow this instruction and adds a bunch of text before and afterwards. But okay, no big deal. We know how to fix this. We're good prompt engineers. So we get a little bit more descriptive, and we give the model a clear description of exactly what to do and give it examples of things not to say. And of course, the model doesn't follow the instructions and actually adds the exact language that we told it specifically not to include in the text. So then the frustration starts mounting, and you start writing out these long paragraphs of instructions and even add some, desperate text. Saying if you include any non-JSON text in your answer, even a single character, an innocent man will die. And just to reinforce it, for good measure, we say at the end, there is no second chance. You cannot undo death. And this works. And we think many of you have probably experienced something similar when working with any language model. This example is from Bard, but all the language models do this, right? And we don't think this is necessarily the best way of doing things. So this is why we created Guidance, a new way to think about interacting with your language models and really make sure that they behave the first time around. Guidance is a new programming paradigm for language models. And I want to get into what we mean by programming paradigm. To start, let's talk about traditional prompting. This experience, what most of us are familiar with, is kind of just a text in, text out interface. You send some text into the model, it does whatever it wants, and you have no guarantees on what the model's spitting back out. With Guidance, we think of this in a new framework of language model programming. So instead of writing plain text prompts, we, as software engineers, get to write these rich, expressive programs filled with code. And Guidance sits directly in the inference stack of these language models, which for the first time makes it possible to truly control what these models are doing in ways that you just can't do with the traditional text-in, text-out interface. When you do this, when you kind of rethink this interaction paradigm with language models, you get all kinds of really cool benefits. You get significantly more control, you get higher quality outputs, and surprisingly, you can get faster execution and lower costs too. And when I say that things get faster and cheaper, we're not talking like 2% here or 5% there. In some workflows, we've seen 60 to 70% reductions in wall clock time and reductions in cost to you. We think that these benefits, and our lovely open source community are why Guidance has started growing and getting adoption in open source. We're lucky to be at over 17,000 GitHub stars, and we're continuing to grow fast. But before I get into all the details of how Guidance works, I want to talk a little bit about the different paradigms that people use today to interact with language models. And I want to start with fine-tuning, which works okay for specific needs, but it adds a lot of complexity to your stack. First, you have to collect a whole bunch of data, and then you actually have to figure out how to fine-tune a model, how to change its weights and parameters, which takes a fair amount of expertise. You need to know if you're doing full weight tuning or parameter efficient tuning, how to set your learning rates. It is a tricky process, and once you fine-tune a model, you're not quite done yet. That model often loses a lot of its generality once you fine-tuned it for a specific task. So you can't really easily repurpose it, and when the world changes, you have to go through this whole motion again. So there's a lot to be said about fine-tuning, but it's cost prohibitive, it can be expensive, and we're not going to focus on it for the purposes of this talk. What Guidance is doing is not fine-tuning. Now let's talk about prompting, which is a paradigm that we've all been familiar with since the GPT-3 era kind of started. And with prompting, you don't change the weights of a model, and you don't need any extra data. You just get to tell the model in plain, natural language exactly what you want it to do. But as we saw before with that example of the JSON, prompting has its challenges and limitations too. And I want to dive in a little bit more to these challenges and limitations. Let's do that by taking a concrete case study. So let's say that we have a medical customer, a customer who wants to extract data from these kind of unstructured doctor's notes and transform that data into rich, structured, precise summaries that can be used for things like plugging in to downstream software, sending reminders to patients. Remember, our world of traditional software really operates on structure, right? And in this example, to do this with a language model in the prompting world, you do something like this. You write out one of these long prompts, maybe 1,800, 2,000 characters, that goes into all kinds of detail, precisely detailing what you want the model to do, what tone it should take, who the audience is, safety features. These things can get kind of long, and there is this art to kind of figuring out how to write them properly. And crucially, as part of all of these prompt instructions, you also have to express all the constraints you want the model to follow. And that is a really inexact science. These constraints are very specific instructions that the model must follow. And we as a research field don't exactly know the right way to do this. There's dozens of papers debating, should you type in all caps for these? Should you put them in bullet points? Should you write it in Markdown, right? There is a lot left to be figured out on constraint expression. And finally, at the bottom here, I just have an example of one of the doctor's notes that we might want to do this extraction on. So this is just kind of an unstructured jumble of text that we want the language model to process and make clean for us. OK, one thing to point out, as each of these things grows in size, as we write longer and longer prompts, our costs and latency also increase because the language model just has to process more text. So we take this combination of things, this beautiful prompt that we've written, and the data that we want to process, and we pass it off to a language model. And this could be any language model, one of the Baby 5 models or a ginormous GPT model. And what we hope to see on the output is one of these beautiful structured JSON outputs that, again, our downstream software will know how to parse and process and integrate with. And I want to take a sec to level set a bit and dive in one level deeper. Let's talk about how this works on the back end when the language model actually processes this text. I'm sure that this part of the deck is familiar to many of you, but just give me some latitude here. I think we'll level set a little bit and use that as motivation to get into guidance. So for simplicity, I'm using this little neural net icon to represent all the language models. They all fundamentally work the same way. And the first thing to understand is that language models don't just generate all this text at once. Instead, they generate one token at a time. And a token is just a collection of characters, anywhere between like 1 and 20 characters. And you can kind of think of it like the alphabet that a language model reasons over, right? Just like we have our alphabet that we string together to make words, the atomic unit of a language model is a token. And I've kind of visualized the tokens here in different colors, so you can see exactly how the language model is looking at this text. And when we start generating, these language models generate text one token at a time. And the way this process works is built around a fundamental principle of next token prediction. So the language model's one job is to take everything that it's seen in its input and calculate what the most likely token is that would follow the text that it's seen so far. What is the most probable next token to complete the text that it's been passed in? So the language model takes everything in, and modern language models have a vocabulary size of like 100,000 or sometimes even 200,000 tokens to choose between. So the language model's job is to assign a probability to each of these tokens. When we're doing a forward pass of the model, ultimately what we're trying to build is this probability distribution. So for every token in our output space, what is the probability that that specific token follows the text in the input? This seems, simple enough. But to do this properly, we need to use a bunch of GPUs and do a bunch of matrix math and complicated GPU operators. And this is where the expense of using these systems really starts to rack up. Once we have a probability distribution, we're not quite done yet. The language model needs to now select a choice, make a choice, and select a token. And we call this next part of the process sampling. So you might think that this is easy. You just pick the one with the highest probability, but it turns out that's not always the best case. You might be familiar with this parameter called temperature. Adjusting the temperature allows the model to choose how much it wants to follow the distribution it calculated. So if you ramp the temperature all the way up, the model gets to ignore this distribution and essentially sample tokens randomly. But if you set the temperature all the way down to 0, then it's always picking the most probable token. Anyway, there's a bunch of different ways that you can tweak the sampling process, but the big picture point is that these models always calculate these probability distributions and then sample a token. And when we do that, once we've sampled a token, we take it and we add it right back to the input, and then we repeat this process over and over and over again. So we move on to the next token, and now the model has seen all the text that we passed it and this one curly brace that it sampled. And then we do a forward pass. We calculate these probability distributions. We pick a token. We add it to the input, doing all this on GPUs, of course, and then repeat over and over and over again, grabbing one token at a time. And once we've done this 150, 200 times, we end up with one of our beautiful structured outputs. But here's the critical question, right? How do we know that the language model picked the right token every single time in the magic of probability sampling? If we missed one comma or one quotation mark or one curly brace, then this JSON is going to be malformed and just completely useless to us. So what most people do today is they pass off their initial prompt, they get a response, and then they write a bunch of validation code to check if the output is what they expected it to be. And if it is, then we're happy and life's good. But if it isn't, then we have to try again. And we fire off another call to the model. Maybe we're changing the prompt or the temperature. And you can get stuck in this kind of prompt, validate, retry loop, which is driving up costs and latency. And it's just frustrating. It has no guarantees that it's ever actually going to work. So what we're trying to do is break this cycle. So that brings us to the third way of interacting with language models, something we call constrained decoding. And this is where guidance comes in. Guidance is a library that encapsulates both prompting and constrained decoding to fix the issues I just described and give developers a lot more control over their language model outputs. I think the best way to understand guidance is to kind of draw an analogy to how the traditional software stack for CPUs has evolved. So if you think about how we write code today, we have beautiful tools like compilers, where we as developers get to write code in very friendly, high-level languages. And the compiler takes that instruction and translates it into very low-level, hardware-level operators and does it optimized and efficiently for us, right? Whereas we as devs don't really have to think about these low-level hardware interactions. And just like a compiler does for CPUs, we wanted to make software that sits at the low level of language models and directly optimizes all of the interactions with the LM. We just saw that language models are doing essentially the same exact thing for every single token they generate. We believe that there is significant optimization opportunity there. To do this in guidance, I mentioned this before, but our guidance users write guidance programs. They're not writing prompts. And by that, guidance program sounds fancy. Guidance is just a Python library, so all you're doing is writing Python code. But crucially, these Python codes are interleaving, these guidance programs are interleavings of Python code and text. And the intuition here is that some things, like really precise constraints, are way easier to express in code. And some things are like more abstract concepts, like tone and audience, are way easier to express in text. So guidance is trying to let you use the best of both worlds, code where you need precision and plain text where you need abstraction. And on the right is kind of an illustration of how we would write that doctor's note example as a guidance program. The details aren't super important. We'll walk through them. But just wanted to give you some intuition that it is like plain Python code. It's nothing fancy. Once we have these programs, we can do all sorts of really, really cool optimizations. And I'm going to tell you about a couple of them. The first one we do is called token injection, where we completely skip over the language model for tokens that we know need to be in the output anyway. Again, drawing back to that compiler analogy, this is like speculative execution on CPUs, except we're never going to make a mistake. We're guaranteed to always be right. Let's walk into the details of how this works. So the intuition here is that developers like us know the structure that we want to see in the output, right? And everything I've highlighted here in blue, these keys of the JSON, the curly braces, the quotation marks, all of these are structural tokens. They determine whether or not the JSON is valid and whether or not it meets our specification, right? So if any one of these isn't correct, our parser and our downstream software are just going to break. So here's the key insight. Why should we have the language model generate all this text that we know is going to be in the output anyway, that we know has to be in the output anyway? Let's talk about how guidance changes this workflow. So guidance sits in the inference layer of the language model. And guidance takes in this guidance program and notices that the first 17 tokens that the user is requesting are completely deterministic. The developer has specified that these have to be in the output. So there is no point of going through that whole process of doing a forward pass, building a probability distribution, sampling a token, and repeating one token at a time. Instead, we can just skip over the language model altogether and directly inject these 17 tokens into the model state. Like, this isn't totally free. We still have to tokenize this and update our KV cache and do some work. But modern pricing structures indicate that this skipping of the LM costs about 1/3 as much as generating the text one by one would. And it's essentially instantaneous, so it goes way faster than slowly generating one bit of text at a time. Then we get to a point after the first 17 tokens where we actually need the language model to do something. So in this case, we've generated all of our JSON up until the ID field, and now we need the model to write an ID for us. This isn't deterministic, so we do the usual routine of doing a forward pass and sampling a token. And then guidance notices that the next 7 tokens are completely deterministic again. So we get to skip over the language model. And we repeat this process of skipping over the language model whenever we can and sampling from the model when we really need it to finish our generation. I want to point out that in these tokens we're skipping, we're going way faster, we're reducing GPU utilization, and we're also eliminating any possibility of errors or hallucinations. Like, there is no chance to get it wrong because this is developer-specified information. So this is kind of where this combination of speed, quality, and cost improvements all come in at the same time. And in this partnership, in this case study that we did, 70% of the output tokens were completely skippable. I'm going to tell you about a couple more optimizations. We're not done yet. So the next thing we do is called masking. And this enables us to start manipulating these probability distributions as they come out of the model and just remove any options from consideration that don't match our specification as developers. So this one's not going to save you any money or any GPU cycles, but it is going to dramatically increase your quality and make sure your outputs match your specification. In masking, first we need a constraint from a developer. And guidance lets developers tell us what they want their output to look like in a variety of ways. You can write just arbitrary Python code, just pass in a function, or you can use something like a regular expression or a context-free grammar if you're familiar with those. In this case, we're using a regular expression and saying, hey, this ID field, it really needs to be a number. My software is not going to work if you just write a paragraph of text in there. So the developer has passed us this info, and then guidance looks at that, and once we're generating the value for ID, guidance does a forward pass on the model, and then before the model does that sampling step, it scans the token list and crosses off any options that don't comply with the dev specification. So it'll notice that 1 is a number, so it's good to go. The word ID is not, so we cross it off. We kind of go through the token vocabulary, eliminate invalid options, renormalize the probability distribution, and then sample a token. And what's important here is that the model is still making a choice. The model has still built the probability distribution, and it's still doing the sampling. We're just preventing it from picking something that doesn't match our spec. So we're almost putting just bumper rails on the model to make sure it stays in the lane. OK, those two optimizations, this injection and masking, are just a start. And if you think of those as basic building blocks, we can start to do all kinds of fun and interesting things. The first one I want to tell you about here is something that guidance users love today. It's a function called select. And this is just a simple case where you want the model to pick between a list of options, right? Maybe you're doing some kind of classification. In the medical example, there was a part of the JSON where one of exactly 7 values must be chosen for filling out a value of a field. Think of it like an enum, right? So guidance users get to take any old Python list and pass it off to the select function, and we will guarantee that the model writes one of these options. And let me walk you through how this works under the hood. So the first thing guidance does is it tokenizes the text. Remember, these language models process tokens, not text, so we always align ourselves with how the models are thinking. And just for reference, everything that the model has seen so far is kind of in its current state here. Then so we've generated a whole bunch of the JSON already. We're just getting to this region in body field. First thing guidance notices is that every single one of these options shares a prefix token. They all start with a quote and an angle bracket. So we know that this has to be in the output, and we don't need to actually generate it. We can just inject it using that token injection trick we talked about. So we add that straight to the model state, skipping over the LM, and move on to the next set of tokens. And now there's 7 different options, and we actually need the language model to make a choice for us. We need its power and context and intelligence of having seen all the text before, right? So what guidance does is it notices that all of these are different, and we can do a masked generation. So we pass these off we pass off the context to a language model. We get back a probability distribution. And now we can go cross off anything that wouldn't lead to one of the 7 options that the developer asked for. Let's say the model locks in to this CHE token. We add that back to the input. And now guidance recognizes that the only thing that started with CHE in the entire list of options was the word chest. So we can just skip over the language model again for the rest of the generation without having to generate those, because there's nothing else that complies with what the dev wanted. Again, we get to inject things, skip over the model, and what would have taken up to 7 normal forward passes on the language model, we can do in just 1. And we're also guaranteeing that we match the user specification. We are never generating anything that is not in your list of options. I won't have time to kind of get into the details of this one. We have tons more of these like syntactic sugars and nice high-level functions in the library. But I wanted to tell you about one of my favorites. It's called substring. And substring guarantees that the model will write a quote or any valid subset of text that is seen before. In the medical example, they wanted a supporting quote for every one of the findings and recommendations that they extracted. But you can think of this broadly when you're trying to do quotations or citations or things like that, when you have a piece of reference text that you're trying to ground the model's output in. Again, I can't get into the details of how this works efficiently, but I do want to call out one thing. You have to be careful here. Just because guidance will force the model to pick some substring of the text, it doesn't mean the model will pick the right substring, right? We're just putting bumper rails. We're not changing the model in any way. So if you have a very bad model, it might just write the word no or the number 12. Like, all of those are technically valid subsets of the doctor's note. So you still need to prompt, and you still need to be careful with your pipelines. But what we are guaranteeing is that anytime the model writes a substring, it will be a legitimate quote from the source material. By the way, we get to optimize along the way, too, and skip tokens. So when we layer in these select and substring optimizations, that medical case study bumps up to 85% of the tokens being skipped. So it's getting dramatically faster. But we didn't want to stop with just some internal collaborative case study that we did. We wanted to verify that all these tricks work in a reproducible open source way. So we looked and tried to find, we found this LangChain chat extraction benchmark, which we believe is the most popular JSON extraction benchmark in open source. If there are other ones, please point them our way. And we ran it against 3 different models, Phi, Mistral, and Llama, just to verify that this is working across different model families. And the first thing we did was run against this benchmark. This is just measuring whether or not the models produce valid JSON back out. And the models all do terribly, right? We ran it out of the box, and this isn't the model's fault. These benchmarks aren't quite configured to align with how the models want to do things. So most of the models get 0%, and Llama gets 30-odd% here. But then we put on our kind of prompt engineering and data engineering muscle and tried to give the models as much help as we could, right? So we spent a fair amount of effort writing a bunch of validation code, parsing the outputs, doing fuzzy stuff. And when we do this, when we make our best effort, these models start to do dramatically better on this benchmark. And surprisingly, the baby phi model is getting well above 90% here. So it's, these models can do really, really well if you're willing to put in that level of effort. But the great thing is, when we just add guidance, we can get a perfect 100% accuracy right out of the box with way less effort. And it's not just quality and accuracy that matter. We also get to do cost reductions and efficiencies along the way, too. So here we're plotting two things. How much time did it take to run through the benchmark with and without guidance? And how many of the tokens in the output did we actually have to generate? You can see here that for the Mistral 7B model, I'm just showing one for simplicity, but all the models essentially operate this way. Guidance takes 20% as much time as the unconstrained version to work through this benchmark. So you're getting an 80% wall clock time reduction and generates less than 10% the tokens that the traditional approach needs. One thing I should caveat, you're not going to see these types of gains on every single task that you do. Guidance really shines when you're working with structured data. But there are a surprising number of tasks where you will see significant speedups and benefits. And I also want to point out every single benchmark we did here is fully reproducible. It's on our GitHub, so please look at it, scrutinize it, check it for methodology, all of that. OK, now maybe the part you've been waiting for. Let's jump into, I've talked a lot about guidance. Let me show you what it actually looks like in the wild. And let's kind of walk through an illustrative example together of how we actually take a problem and write some guidance code for it. So I'm going to jump over here and switch my screen. All right, so let's get into some code. So the first thing, as I mentioned, guidance is just a Python library. So all you do is pip install it. It works on every operating system. And then you start guidance scripts with loading up a model. And we support a whole variety of platforms here, some with deeper support than others. But in this case, we're using the popular Hugging Face Transformers library. And we're loading up the Phi3 mini model. And you can set all your kind of parameters that you want here. OK, let's jump into a problem. And just for the sake of the demo, we're going to do a really simple math problem together. So I pulled this from the GSM 1K dataset that was released by Scale recently. And they're meant to be 8th grade style math problems. And it's really simple. It says 30 students are in a class. Some fraction of them are 12. Some are 13. Some are 11. How many of them are not 11, 12, or 13 years old? And with great effort, I did the math. And in the comments, we know that the real answer is 11. And I checked this with a calculator, too. So remember that. The answer to this question is 11. And the first thing we'll do is just a very simple basic prompt, no fancy constraints or anything. And so you have this language model. And the way guidance works is you kind of load things onto the model. So with this plus equals operator. So the first thing we do is we're just passing off the question straight to the model with a little bit of prefix text. And then we're asking the model for an answer. And this gen function is when we start generating things from the model. And in interactive notebook environments, you'll get this kind of pretty output where you can see exactly what the model's passed in. And in highlights, you'll see what the model generated. So we pass in the question, we ask for an answer, and unfortunately, the model gets the wrong answer. It says 6 students are not 11, 12, or 13. Remember, the real answer is 11. But we can do better. We know that there's more tricks than just basic prompting. So now I want to show you the kind of power of writing these guidance programs. And by the way, this isn't the most optimal way to solve an 8th grade math problem. I'm just using this as an excuse to show off guidance features to you all, right? So we'll write a more sophisticated prompt, and then let's get interesting here. We'll ask the model to pick between writing out its steps first or directly writing the answer. So we're saying, hey, help me with this math question, and we'll pass the question in, and say, should we write out our steps or should we directly answer the question? And remember that select function we talked about earlier? Well, the model gets to now pick, does it want to write its steps or does it want to write the answer? And then we can do all kinds of things that we know and love with Python, conditionals, loops, every kind of Pythonic data structure that's out there to help us build a program around this. So we'll make a simple if statement branching on the choice that the model makes. And if it wants to write steps, then we give it some more generation time. And if it doesn't, then we'll just ask it for the answer directly, right? And this notebook and everything else is on our GitHub, and we've got much better tutorials there. But now we can look at what the model outputs, and we'll see that the model, first off, all this plain text at the top is what we've passed into the model. And then we've seen that the model chooses to write the word steps. And notice it only generates one of those tokens, not all of them, because we get to optimize. And now it starts writing out its steps, and it says, hey, let's find out the number of students who are 12, the number that are 13, the number that are 11. We'll add them all up together, and then we'll subtract them from the total number of students. Seems like a pretty good plan. And once the model executes on that plan, we see that it arrives at the right answer. This is a technique called chain of thought prompting, if many of you might be familiar with it. But guidance makes the ergonomics of doing this easy and integrated as a first-class citizen in the language. And now we've got this answer, but let's say we wanted to extract something from the model, right? Like, this isn't easy to parse. We just want the answer back out. And instead of having to write a whole bunch of parsing code, we can just ask the model to give us an extractable summary. And we'll say, hey, therefore, in summary, the final answer is, and ask the model to do a constrained generation with that regular expression we talked about before. So we'll force the model to summarize its answer as a number. And when we do that, we're not re-prompting or recalling the model. All of this is saved in the model state. We're just adding this little bit of generative text at the end, and we get a beautifully parsable, extractable answer stored on our language model objects for further use. There's a lot more really cool stuff you can do with guidance. It aligns with all the chat templates that models use. You can put them in these really reusable functions, and once you write a function once, it runs on any language model, so you never have to customize your code to different frameworks ever again. Transformers, Llama CPP, remote models like OpenAI, these functions run on all of them with different degrees of efficacy. All right, now that you've seen a little bit of code, and I promise it's real, you can check out the GitHub repo for a lot more examples. I want to switch back to the deck and kind of walk you through some more fun stuff at the end. OK, so far we've been talking about like math problems and data extraction and kind of businessy things. I want to kind of open your eyes to what happens when guidance lets the world of traditional software blend the world of language models with a more visual, like fun example. So here we're going to try to get these models to play chess, and none of these models have actually been trained on chess, so they're all terrible at it. On the left, we're going to have the model just play against itself with traditional prompting, and on the right, we're going to put guidance in the mix. And you'll see the text being generated here. And you'll notice, so first thing to notice, on the right side, guidance is having the models make legal and valid moves like every 0.4 seconds like clockwork. But on the left, these models are just getting stuck in loops. They're writing all kinds of weird things. And when they do make a move, they often make like totally illegal and invalid moves. They're teleporting pieces all over the place, right? So, what takes like a minute with a whole bunch of retries in the traditional prompting world, you can get this like beautiful example of chess working with guidance with fairly minimal effort. OK, to be fair, like the model is terrible. I'm pretty sure it like sacked like half of its pieces, but like that's a detail. The fact is we can put the bumper lanes on and force the model to make valid moves. And we have so many more examples in the wild. We've got some of these are on our GitHub README. Some of them are just out in the ecosystem. We've got examples of how to do RAG and connect to search engines. We've got examples of using guidance to make perfect function calls every time if you're trying to have agentic workflows where models are using tools. Code generation, token healing. We're really excited about a lot of the work on using guidance for more responsible AI, preventing kind of harmful content from being generated. And maybe some of you have seen our MedPrompt work, which is like a super fancy prompting technique that we built for the medical use case. All kinds of things are on our GitHub README and kind of out in the wild. As we come to a close, I just want to remind everyone that guidance works best when it sits next to the model, like directly integrated into the inference layer. That's what we need to do in order to do this kind of prompting. We don't need to change the models. We don't need to change its weights, retune them, or anything. But we need that kind of supervisory software in the inference layer. And today, we work on all of these platforms, most model providers that you can think of. But we obviously work best on some model providers, particularly those that run locally, where we have that level of control, where we can integrate into the inference stacks. So if you're using Transformers or Llama CPP or our new open source Phi3 models, you'll have full guidance capabilities there. What I'm really excited to announce is that we are bringing guidance to the cloud for the first time with the Phi3 line of models. So in the Azure AI hosted versions of these models, for the Phi-3 line to start with, you'll have the full power of guidance, all of the quality, efficiency, and speed improvements without having to manage the model yourself and just deal. You can do it in a much more scalable way when it's hosted on Azure versus a local model. This will be coming soon, and we're just super thrilled about it. So if anyone's got questions about this, we're happy to talk. But thanks. Yeah, it's been an unbelievable amount of work to get that integrated, so thank you. But you don't have to wait right now. Like I said before, we have a very vibrant open source offering. We work on basically every local model out there, everything on Hugging Face, everything in Llama CPP, right? And we have a ton of rich tutorials and kind of a very vibrant community, actually, that will help you get started and answer questions on our GitHub page. We also encourage you to check out our new channel on Discord if you want to engage with us directly and kind of chat with us. That's at that link over there, aka.ms/guidanceai. And with that, I guess I'd like to open it up for Q&A. I'm joined here today by Dean, Nick, and Richard over there at that table. And then online, we've got a couple other members of the team, Farouk, Xavier, Mickey, and Sarah. So feel free to ask questions on Pubble or just right here in the room. But thank you. Thank you all for coming. I think the mic is floating around, so hopefully it will make its way.
Hello.
Hi.
Thanks for the presentation. Really interesting stuff. I'm curious. I think I noticed in your code examples, you also integrate with closed source models as well, like the OpenAI. And specifically for the token masking section, I'm just curious. It appears to me, at least off the top of my head, that would be something that you need to modify the last layer of the model. So I'm curious, just how did you manage to integrate it with closed source solutions?
Yeah, it's a great question. So we have, our level of feature support gets much deeper when we have open integration. We can do some things like logit biasing and tricks where we can do some hand-wavy integrations with closed source models, depending on what their APIs support. But it is much less feature complete, and our ability to do things like really deep masking or token injection definitely are not the same when we have a totally closed source platform. Guidance then just kind of becomes a nice prompting library with just some syntactic sugars and some extra validation code. To get the best performance and all these tricks that we talked about, you'll have to use the Phi-3 models on Azure soon or any of the open source models, right? And we're working on bringing more and more integrations in the coming weeks and months.
Sounds good. Thank you.
Great question.
Hi, nice presentation. Do you have a list of features that work with the closed source models, like the structured, generating the structured output? Does that work with the GPT models?
It doesn't, we can't provide hard guarantees on the structure generation with the GPT models. All of the details of like what works and doesn't work are on our GitHub page. So I'd encourage you to go check that out. We wanted to still build early support for these, so there's like portability and you can verify your prompts against other models. But for best performance, the ones that are kind of got these decorated curly braces are the ones where you can get hard guarantees on your output. And as mentioned, we're working on more and more integrations as time goes by.
Thank you.
Hi, thanks for the presentation. Have you tested this with multiple languages, like Japanese specifically? We're having trouble with formatting of outputs in the Japanese language.
Yeah, we have. Fundamentally, your constraint expression and the way the models are processing text, like it all boils down to tokens, and there's many tokens in the tokenizer that represent Japanese characters. So you'll have no problem as long as you can write a constraint for it. And again, you can do that with just like arbitrary Python code, right? To have guidance and force that constraint on the outputs that are being sampled. So multi-languages are not an issue at all.
Perfect, thanks.
Hi, good presentation. Is there still no plan for a C# implementation?
We've got a long roadmap ahead. I think we can't comment on like totally, I have no idea what the exact future plans look like. Right now, we don't support C#, but we've heard a lot of requests for it, so it's something we'll take under advisement.
Thank you.
I'm wondering how you, well, thanks again for the presentation, really interesting. I'm wondering as you look at other areas of programming where there's a lot of strong typing, I can't think of the library in Python today, it's like on the tip of my tongue, but they use it for fast API.
Like Pydantic?
Yeah, Pydantic, there you go.
Yeah, we have full Pydantic support
So
too.
like interoperability between the typings, have you noticed any kind of thing, anything you do differently as you're thinking about a Pydantic model and how that works for typing and APIs versus in this model context, or kind of maybe some unique things to think about it differently in one or the other?
Yeah, it's a great question. You're right, Pydantic has kind of been backfitted to be working on like language model constraints, even though it was designed for API specification. There's some boundary cases where you get like weird issues with JSON schema and Pydantic conversion, like specifically around how they deal with like floating point numbers and things like that. But for the most part, it's pretty seamless. I will say that with guidance, we have these syntactic sugars where you can just pass in a Pydantic schema and we will generate text that conforms to that schema. If you want to fix some of these issues, you can always drop a level lower and just modify the schema generation piece. So it's a syntactic sugar. It's not like a fundamental piece of the language, right? But yes, there are rare boundary conditions. We don't find that they affect most people when they do this. And since you mentioned programming languages, we also generate text according to context-free grammars. So if you want to generate like syntactically valid code of a programming language, you can specify that as a guidance grammar, right? So it goes way beyond just JSON schemas. We just use JSON for this example in the talk.
Hi, thanks for the presentation. Have you guys tested this guidance library with other toolkits like LangChain or Semantic Kernel?
Yeah, it's a good question. Guidance kind of sits at a lower level of the stack, let's say, than LangChain and Semantic Kernel. So we've seen people in the community like use these successfully together. We haven't done a ton of testing on that, like personally ourselves, but I almost think of it as like an underpinning layer that other libraries might be able to benefit from. So we've seen examples in GitHub of people having LangChain agents call guidance programs and enforce structure as part of a bigger agentic workflow, right?
Yeah, it makes sense. So I guess you could have that language model from guidance as a parameter or an attribute within your plugin you're building in Semantic Kernel or something to work?
Yeah, absolutely. Now, to be clear, we haven't done this yet, but we've seen community, like our open source community kind of do things like this.
Awesome, thank you.
Very cool stuff. Very simple question. Time frame for Azure Phi 3?
I don't know exact timeframes, but coming very soon is the best thing I can say.
Okay, thanks.
Sorry, just another follow-up question,
Yeah.
since I like the presentation so much. The gentleman mentioned Pydantic, so it triggered another smaller question. I use Llama Index a lot, and my go-to strategy so far to enforce a certain structure has been using Pydantic programming, which underneath, at least for OpenAI, for example, uses function tool calling, where they have a predefined schema and they enforce that. Is the implementation, at least on high level, similar to that structure behind the scenes? I'm just curious about that.
Yeah, I'm not entirely sure about what Llama Index's like Pydantic programming looks like. I'll have to check and see what they do and what their stack looks like. So I don't know off the top of my head, but in principle, if they're working with a closed API like OpenAI, they probably have the same limitations that we do. So maybe they're piggybacking off of function calling, but there's fundamentally different ways of operating there, right?
Sure. Yeah, I guess maybe I'll rephrase it. I meant more in comparison to the function tool calling specifically, let's say for OpenAI, if you were to make a comparison with that. We can just ignore the Pydantic part.
Gotcha. I think function calling, I don't know exactly how OpenAI achieves that. Like, that's kind of in their stack. If it's a fine-tuning kind of process, it's still much more restrictive and limited in like the types of output structures you can specify. I don't know exactly what their implementation looks like, though, so I don't know if technically it's the same as what we do.
Okay, makes sense.
I think OpenAI says that their function calls can still make mistakes, though, so I would bet that it is like a little bit different, right?
Yeah, and I've experienced that as well. So it's,
Right.
Thank you.
Thanks, and this is just a clarification. There's some chat online. What we announced today was guidance support in Azure for the Phi 3 family, coming very soon. The strategy is to have guidance working on all models in Azure. We don't have a time frame to announce for that, but just I hope everyone will take away that the announcement today is the Phi 3 family soon and eventually spreading out to the entire catalog of models.
Thanks, everybody. We'll be hanging out at the table if anyone's got like further follow-up questions.